Good afternoon. My name is Costa, and today we're going to talk about integrity, an object-relational framework for data security. My coworkers are João Pedro Lorenzo, Carlos Eduardo Pantoja, and Nilson Mori Lazarin. We are from Brazil, and we are here for the Cefet institution. First of all, Database Management Systems, or DBMS, provides native encryption functions such as AES encryption for MariaDB and MySQL, PGCrypto for PostgreSQL, DBMS Crypto for Oracle, and Encrypt by Key for SQL Server. Uh, DBMS have some limit factor in providing the security information for all the stored data. Some cryptography functions are restricted to certain types, such as date, int, decimal. This work aims to present integrity, which is an object-relational mapping framework. It's based on combinations of existing cryptography algorithms to mask data. It was developed using C-sharp program language, tested through a proof of concept to demonstrate the assertiveness of its main features, and for the initial version, it's used to encrypt varchar data and mask data in relational databases. For related works, we've based it on the TEO, Transparent Encryption for the Database Abstraction Layer, from Carl Lowry, Eric Buckman, and Clemens Baum. This work says that data security is guaranteed as there is no need for the storage service provider to obtain data encryption keys. Besides that, the database abstraction layer is a way to translate different specific command of the existing DBMS on the market. We've based integrity on this specific concept, and we created our own database abstraction layer. Integrity is also related to DebiCrypto, a database encryption system using query-level approach. This works from Azavar Desfande, Anup Patil, Saurabh Josh, and Suraj Bhattara. It encrypts data by rewriting queries using the Vigenère cipher, which is a form of simple sum of numbers encryption. It also stores the key in the application, and therefore whoever has access to the data in the database will not be able to see his real value because the key is not stored at the database too. So he needs to know the keys that are stored in the application. At this point, integrity is related to this work because we configure the library with the keys that are stored in the application. Also, there is a different operation for each type of query, and at each call, the query changes to adapt to the encrypted database. This is also a concept in the integrity because we need to manipulate the query command. Another related work is LGPD compliance, a security persistence data layer. This works from Paulo Pita, Elder Costa, João Pedro, Lorenzo, Siqueira, and Nilson Mori Lazarin. In LGPD compliance, the author's main objective was legacy system, using a technique to perform a dump of the original base and change the type of stored data and change the structure of tables, and after all applying AES for disk persistence. In this technique also was employed data tables in primary memory with data obfuscation to speed up queries. They use query modifier codes to store that in the database. We use several of the concepts presented on the related works. Different from TEO, our proposed approach allows comparison with an obfuscated data without the need to decipher, consequently speed up query processing in this case. In addition, we use Advanced Encryption Standard or AES to cipher data type varchar differently from DebiCrypto. Our proposed approach uses a modern cryptographic algorithm that uses the object in the application to generate the key that will cipher the varchar data type. And instead of the LGPD compliance, this work presents a data obfuscation process for disk persistence, keeping the column's original data type, which is an advantage for our model. And now we enter the integrity framework indeed. It is an object-relational mapping framework, as I said before, where data encryption is performed by several rules and steps to obtain and generate a token to encrypt varchar data types or obfuscate the data types. As you can see at the schema of integrity in the slide, Once that data is sent from the model layer to the persistence layer, Integrity performs an object-relational mapping, transforming the object model into a relational model prepared for storage in the database. So the integrity works at the persistence layer, as you can see, and the object properties are used to get the token, get the key and then the token, and the data masking process obfuscates the data using FASTO and ASCII special cipher. And if the data is a string type, the data is encrypted with AES encrypt. Integrity SQL automatically assembles the SQL query for the data store. So we manipulate the query command to perform the SQL command at the DBMS, and the reversal process it's also possible. So in case of a query to retrieve encrypted or masked information from the database, a SQL does the opposite process. Take the encrypted string data and leave the text unencrypted for the model for the application layer. The data masking process, it receives the data to be manipulated, a 128-bit key defined by the developer in the system source code. This is defined at the application configuration. An automatically generated seed. This seed is derived from the table structure, initial seed, and the column chosen to be encrypted. The initial seed is also defined at the application configuration, but the table structure and the column chosen to be encrypted, the integrity takes the object's properties to make this seed. So that is why the integrity is an object's relational mapping framework, because we need to define the table, the properties of the object to retrieve this information and generate a seed from that. Consequently, the goal is to increase entropy and make difficult an attack by frequency analysis, since each table column will use a different seed in the masking process. As I said before, the data masking process follows the following steps. The encryption key K is submitted to the AES key expansion. This key is that key that the developer defines at the startup of the application, and it generates 10 new 128-bit subkeys. So by the given key, 10 another subkeys are generated by the AES key expansion. The seed that is automatically generated is submitted to SHA-256, generating a fixed length 256 bit output that is later split into two parts, right side and left side, both 128 bits. The two parts of the SHA-256 digest and the 10 subkeys are subject to a 10-round FASTO network. For each round, a logical operation SHOR is performed between the round subkey with the right side. So the first process is the first key subkey pass for a SHOR with right side. This output performs a SHOR with the left side, and now the left side becomes the new right side. In here too, the right side, after the performed SHOR with the first key and the subkeys, becomes our new left side. This will continue until we have a token of 256 bits. This token is submitted to a function. For date-type data masking, the 256-bit token is converted into an integer, representing the amount of leaps that will be added to the data to be obfuscated using the following. Date mask, masked date, is equals to clear date plus token mod n. This n fields represents the limits of the chosen DBMS. It is responsible for the leap assigned to the overflow of the field limit. For varchar type data encryption, the AES algorithm is used. In this case, the 256-bit token is used as the encryption password using the 128-bit most significant bit, and as the initialization vector using the 128-bit least significant bit. This version of Integrity was built in the C# language using the .NET Core 5.5 development platform and the Visual Studio IDE. The development considered only the MySQL DBMS and only dealt with the datetime and varchar data types. The source code is available in my GitLab. We built a case study based on the scenario where Bob and Alice registered their data on the retailer's platform. The case study will store the customer name, registration date, cardholder name, card number, and expiration date. The fields using varchar and date will be encrypted and obfuscated. As defined from the developer's point of view, we need to configure the integrity in the app settings or in the initial configuration of the application. We need initial password and initial seed. These will be used by our application, by the integrity, to obtain the key and the seed. Afterward, like I said before, it needs to create a class in the business model layer with 5 columns. So we have in here the name of the table, we have the properties of the object, so the column client name, client since date, cardholder name, card number, card expiration date. All of this will be used to generate the seed that will be used to encrypt or obfuscate the data. And these, again, is the object-relational mapping framework that the integrity is. As you can see in the slide, identical dates will be stored to exemplify the behavior of integrity since the jump of each column of the table is different. This makes frequency attack in the masked data harder to perform. If you see in this field request body, when we pass 2 equals date, like in Bob, in here client since date and card expiration date, it transforms to 2 different dates in the DBMS. So this makes frequency attack harder to perform since you don't have the same result. The same to Alice, where equals date has different results. For conclusions, we presented a framework for object-relational mapping that aims to obfuscate the information database, leaving the responsibility of the cryptographic process to the application layer. So we remove this responsibility of the DBMS, aims to make the entire process transparent for the developer, and the laws, developing software considering the new data protection laws is facilitated. Other types of fields will also be using integrity. Today we only use string and dates type, but we aim to use the integer data type. It's not using this version. Thought as future works, we intend to integrate data types with a finite body well defined as the EAAA 754 standard data types. The framework provides the search for exact data in the database or by date range. However, searching for data using a string snippet in an obfuscate field is an open challenge, and we aim to resolve this case. Now we came at the end of our work. This is all of our references. I would like to thank you all for the attention, and it's it. Thank you very much. Bye bye.